The world of design and manufacturing is experiencing rapid change driven by the maturity of industrial additive technologies and aided by AI algorithms. Take the design of a performance automobile. Already lightened and strengthened with advanced material alloys and modern manufacturing techniques, let's see how we can further improve just one subassembly of the system using generative design technologies in Fusion 360. The base component of this pedal is currently comprised of 87 different components, 13 of which are machined or made from sheet metal. To optimize this, we'll begin by pulling off important geometry to be preserved throughout the design exploration. This can be done in Fusion 360 in a number of different ways, but we'll use the patch workspace to replicate existing geometry. Once done, it's automatically sent to the Generative Design setup, where we'll further describe the problem. Starting by defining those preserve and obstacle regions, which will ensure form and fit throughout the generated geometry, while optimizing strength in relation to factor of safety, using loading conditions in conjunction to manufacturing limitations, such as these additive-driven overhang angles and minimum thickness definitions. And of course, we can't forget to define the additive-specific materials. From there, you begin generating the outcomes. And even though generating tens or hundreds of potential solutions is processor-intensive, it will go unnoticed by the user as it is solved in the cloud. This allows the designer to stay productive and will ensure those results are available faster. We have 16 unique solutions available, and it's up to us to find the design that best fits our needs. Luckily, there are numerous ways to sort, view, and compare. Filters will help remove any solutions heavier than the original, and the winner will be exported to a BREP body, ready for post-generative steps. First and foremost, we'll verify that the pedal movements are unimpeded by the new shape, and once confirmed, we'll take advantage of the collaborative environment Fusion 360 opens up by enlisting a team member to help in the CAM workspace. There they'll add locating features, address work holding, and create the toolpaths to meet rigorous tolerances required in such a design. While that's being done, further finite element analyses can be run in context to the assembly, and additional failure criterion and loading conditions can be checked. In the end, the generatively designed replacement, one that will have taken a designer months to realize, will be 15% lighter, stiffer, and stronger, but perhaps most important, there are 86 fewer parts saving on labor, purchasing, and Q&A just to name a few. And it wouldn't have been possible without generative design in Fusion 360.